So, okay, students, so welcome to Dr. Haider Maths classes. So, today we will discuss the 12th class syllabus of the topic three-dimensional geometry. Three-dimensional geometry. Three-dimensional geometry. So, in the three-dimensional geometry, there are 3 points that we have to discuss. The first one is direction. Direction cosines and direction ratios. Direction ratios. These 2 points we will discuss for the first exercise. Then we will switch over to the next point. So direction cosines, these are denoted by L, M and N, where L is the cosine of alpha, cos alpha, M is cos beta and N is cos gamma. Okay, and there is some relationship, sum of the squares of the direction cosines is equals to 1, or we can write cos square alpha plus cos square beta plus cos square gamma, that is equals to 1. And direction ratios are denoted by the A, B and C. A, B and C. And if the direction ratios are given, then how we will find the direction cosine? So direction cosine L is equals to plus minus A upon root over of A square plus B square plus C square, and M is equals to plus minus B upon root over of A square plus B square plus C square, and N is equals to plus minus C upon root over of A square plus B square plus C square. Okay. And if 2 points are given, suppose the point P is given x1, y1 and z1, and Q is given x2, y2 and z2. So the direction ratios of the PQ, direction ratios of PQ, A is equals to x2 minus x1 and B is equals to y2 minus y1 and C is equals to z2 minus z1. So we will use this formula to simplify this exercise. Okay, now switch over to the exercise. Okay, now move to the exercise. That is 11.1. Exercise 11.1. The very first exercise is, if a line makes an angle 90 degree, 135 degree and 45 degree with the x, y and z axis respectively. Okay, so we have to find the direction cosines. So first question number 1. So here the direction cosine L. L is equals to cos 90 degree, that is equals to 0, and M is equals to cos 135 degree, and cos 135 degree, that will be equal to minus 1 by root 2, and N is equals to cos 45 degree, and cos 45 degree is equals to 1 by root 2. So therefore direction cosines is equals to DC, direction cosines is equals to 0, minus 1 by root 2 and 1 by root 2. These are the direction cosines. Okay, now the next question, that is question number 2. And the second question is, find the direction ratios of a line which makes equal angle with the coordinate axis. Equal angle with the coordinate axis. So let L is equals to cos alpha, M is equals to cos beta, and N is equals to cos gamma. And since we know that cos square alpha plus cos square beta and plus cos square gamma is equals to 1, and according to the question, okay, all these angles are line which makes equal angle. So this will be cos square alpha plus cos square alpha and plus cos square alpha, that is 1. Why it will all will be? Because since it is given that cos alpha is equals to cos beta is equals to cos gamma, as per the question, it makes equal angle. So now this is 3 cos square alpha is equals to 1. So cos square alpha is equals to 1 by 3. So cos alpha is equals to, that is plus minus 1 by root 3, right? So plus minus 1 by root 3. So therefore the direction cosines are, hence the direction cosines are DC's. DC's direction cosines are plus minus 1 by root 3 and plus minus 1 by root 3 and plus minus 1 by root 3, right? And this should be the answer of this question number 2. Okay. Now the next question, question number 3, and the third question is given, okay, if a line has the direction ratios are given, means A is equals to minus 18 and B is equals to 12 and C is equals to minus 4, and when what will be the direction cosines? So use the formula. L is equals to plus minus A upon root over of A square plus B square plus C square. So this will be plus minus, and A value is minus 18 upon root over of 18 square 324 and B square 12 square 144 and C square plus 16. So finally it will be this will be equal to plus minus, so minus 18 divided by of root over 6 4 10 4 14 4 carry 1 and 4 1 5 5 2 7 1 8 and 1 1 2 and 3 4 1 and 3 1 4 4 84. So this will be equal to plus minus 18 upon 22. This is the value of a root over a square plus b square plus c square we will use. Similarly, the value of m, what is m? M is equals to plus minus the value of b is this, and this value we have already calculated, so we will write the value of b is 12. Okay, so the value of b is 12. So 12 upon plus minus 22, this is the value of m, right? And n is equals to plus minus 4 upon root 22, or after the reducing we can write, so therefore the direction cosines are, reduce it, then it will be minus 9 by 11, and this will be 6 by 11, and this will be minus 2 by 11. So these are the direction cosines of this question. Okay, so next question is question number 4, and the question number 4 says, show that these 3 points are collinear. Collinear means we will find the direction ratios of these 2 points. So okay, let me erase of question number 1. Okay, question number 4, and the fourth question says, here the points are given. The given points are 2, 3, 4, and the next point is minus 1, minus 2, and 1, and third point is 5, 8, 7. 5, 8, 7. So these are the 3 points, and we have to show that it is, these points are collinear. Collinear means we let the point, this point is say P, this point is say Q, and this point is say R. Then find the direction ratios of PQ. Okay, by applying the formula x2 minus x1. So minus 1, minus 2, the minus 1, minus 2, and minus 2, and minus 3, minus 2, minus 3, minus 2, minus 2, minus 3, and 1 minus 4. So this is equals to minus 3, minus 5, and this is minus 3. So direction ratios of PQ we have calculated, okay, by applying the formula x2 minus x1, y2 minus y1, and z2 minus z1. And now find the direction ratios of QR by applying the same formula x2 minus x1, y2 minus y1, z2 minus z1. So this will be 5 and minus minus plus 5, 1, 5 plus 1, then 8 plus 2, and then 7 minus 1. So this is equals to 6, 10, and 6. Okay, so from this we are coming to the, okay, here is 3 is coming common. Okay, if we will take it, this 2 is coming common. 2 3 is 6, 2 5 is 10, and 2 3 is 6. Okay, so it can be seen that the direction ratios of this are minus 2 times. Okay, so we can take minus 2 suppose as a common. So minus 2 as a common, then it means, or we may write, okay, the direction ratios of QR is minus 2 times the direction ratios of PQ. So these points are collinear. Okay, so therefore the given points are collinear. Given points are collinear. Given points are collinear. Okay, this is the question number 4. And the next question is question number 5. The fifth question of this exercise. Question number 5. And the fifth question is, find the direction cosine of the sides of the triangle whose vertices are given. So this is the triangle, and this suppose is A, B and C, and the vertices are given, that is 3, 5 and minus 4, 3, 5, minus 4, and the B vertex is minus 1, 1 and 2, and the C vertex is minus 5, minus 5 and minus 2. Okay, these are the three vertices of the triangle, and the question says find the direction cosines of the sides of the triangle. So direction cosines of the sides of the triangle. आज मैं क्लास में. So we have to find the direction ratios. The question is find the direction cosines. So first of all, we will find the direction ratios of the side AB. So direction ratios of side AB, that is by applying the formula x2 minus x1, y2 minus y1 and z2 minus z1. So this will be equal to minus 1 minus 3 minus 4 and 1 minus 5 minus 4 and 2 plus 4, that is 6. This is the direction ratios of AB. Okay, and now we will find the direction cosines of AB. So direction cosines of AB, that is by applying the formula plus minus a upon root over a square plus b square plus c square. So this is minus 4 upon root over of minus 4 square 16, again it is 16, and this is 36, then 16 plus 16 32, 32 plus 16, so minus 4 plus minus 32 and 36, 32 and 36, so this is 68. Okay, so root over of 68, and this can be written as minus 4 upon twice of root 17, so we may cancel it, so minus 2 upon root over 17. This is the direction cosine of the AB, that is L. Now find M, right? So this is L. Now find M. Similarly, we can find M. So M is equals to again minus 4 upon 2 root over 17. So it will be cancelled. So again it will be minus 2 root over 17, and N is equals to C upon, C is 6 upon root over 68, that is twice of root 17. So this is cancelled out. So 3 upon root over 17. So in this way we will find all the direction cosine of the all sides. So AB we have calculated, and now similarly we will find the direction ratios of BC, and then we will find the direction cosines of BC, and then similarly we will find CA. So I think you can complete. Okay, I am just giving the hints. In the same way, we will find the direction ratios of BC. So direction ratios of BC means x2 minus x1 minus 5 plus 1, that is equals to minus 4. Okay, and minus 5 minus 1, that is minus 6, and minus 2 that is minus 4. Okay, so direction ratios we have calculated, and now find the direction cosines. So direction cosines of BC, हेलो, हाँ मैं क्लास में हूँ बेटा, बाद में बात करता हूँ। So direction cosines of BC by applying the formula plus minus a upon root over a square b square plus c square. So minus 4 upon root over of, this is again it will be the same because the direction ratios are coming, minus 4 minus 6 minus 4, so it will be 16 and plus 16 and plus 36 and plus 16. So minus 4 upon root over 68. So this is minus 4 upon twice of root 17. So this is minus 2. Finally, it will be minus 2 upon root over 17. And this is the value of L. So now M is equals to N upon minus 6 upon twice of root over 17. So this is cancel out, minus 3 upon root over 17. And N is equals to minus 4 upon twice of root 17. So this is cancelled. So minus 2 upon root over 17. So now we have calculated direction cosines of BC. Similarly, you will find, you can find the direction ratios of AC and then direction cosines of AC. So this segment I am leaving for you. Please complete it. Okay. So this is all about your exercise 11.1. So I think now the concept is clear to you. If you are having any type of doubt, please write your doubt in the comment section. Thank you very much. And in the next class, we will continue exercise 11.2. Thank you.